Welcome back. In this lesson, we shall learn a very common type of dividend discount model, that is, the Gordon Growth Model. We shall first examine the fundamentals of GGM for equity value, followed by learning other applications of the model. This includes calculating the implied growth rate, the justified PE ratios, and the present value of the growth opportunities. Lastly, we'll learn the Gordon Growth Model approach to valuing preferred stock. Quite a bit to cover, so let's get rolling. This was where we left off from the last lesson. We learned that the most fundamental form of the dividend discount model is that the present value of a stock is the sum of the present value of all dividends in the future for perpetuity. As it is clearly impossible to forecast all future dividends, we have to assume from some point onward the growth rate of dividends to be constant. This allows us to simplify all future dividends to one value, that is, the intrinsic value of the stock at that instance. The most well-known model to do this is the Gordon Growth Model. Since we now have a constant growth rate, every future dividend can be expressed in terms of the current or most recent dividend paid, which we denote as D0. This equation simplifies to the Gordon Growth Model, which is the next period's dividend, divided by the required return minus the constant growth rate. This formula looks deceptively simple, but believe me, it can be easy to get the wrong answer if you're in a hurry. Always remember the numerator is the dividend for the following year, which you have to multiply D0 by the growth rate to estimate it. Some candidates will just use the most recent dividend as the numerator, which I'm sure will be one of the choices in the exam to trick you. Alternatively, if the dividend for the next period D1 is known, simply use it as the numerator. Before you use the Gordon Growth Model to value stocks, it is important to understand the assumptions and limitations of the model. The first assumption is that dividends are the correct metric to use for valuation purposes. As mentioned in the first lesson, some early-stage companies pay little or no dividend, so the Gordon Growth Model would not be appropriate in such cases. The second assumption is that the dividend growth rate is forever constant. That is, it is perpetual and never changes. Third, the required rate of return is also constant over time. And lastly, the required rate of return, R, is strictly greater than the dividend growth rate, G. Otherwise, the math will not work. Let's go through an example. XYZ stock recently paid a dividend of $5. The dividend payout is expected to grow at 4% per year indefinitely. Calculate the intrinsic value of this stock today. You may assume the required rate of return to be 9%. Notice in this question, it's not explicitly stated which valuation method you should be using. However, you can infer from clues such as the word recently, which implies that this dividend is D0, and the word indefinitely, which implies that the growth rate is perpetual and constant. So we should use the Gordon Growth Model, where D0 is $5, R is 9%, and G is 4%. Check that R is greater than G, and we can use the Gordon Growth Model. Our first step is always to calculate D1, which is the dividend for the next period. Increase the $5 dividend by 4%, and we get $5.20. The intrinsic value of XYZ stock can be easily calculated using the formula for Gordon Growth Model. Simply plug in the figures, and we get an intrinsic value of $104 for the stock. Now, let's say a second analyst estimates that the growth rate is 4.2% and the required return of XYZ stock to be 8.8%. Calculate the intrinsic value of the stock based on this analyst's assumptions. Now's your turn. Pause the video now to work out the answer. And we're back. Using the Gordon Growth Model, where D0 is $5, R is 8.8%, and G is 4.2%, plug in the figures, and you should get an intrinsic value of $113.26. There are a few characteristics about the Gordon Growth Model that you can infer from these two calculations. Firstly, notice that when the difference between R and G narrows, the value of the stock rises. The reverse is also true. When the difference between R and G widens, the value of the stock falls. Also, the stock value is very sensitive to changes in the difference between R and G. As you can see from this example, even though the second analyst's estimates of the growth rate and required return are just slightly different from the first, the estimated stock value is much higher than the one estimated by the first analyst. The application of the Gordon Growth Model is not restricted to just equity valuation. As the model includes 4 variables, if we know any 3 of them, we can solve for the 4th. In practice, we can typically observe the price and current dividend for a publicly traded stock. Consequently, we can either work out the implied required return using an assumed growth rate, or the implied growth rate using an assumed required return. More often than not, the required return of a stock is assumed constant and can be estimated using methods such as the capital asset pricing model, so what we want to work out is the implied growth rate of the stock at the current market price. In other words, this is the growth rate of dividend that investors expect when they buy the stock at the current price. For our last example, we calculated that the intrinsic value of XYZ stock is $104. This is the value of the stock based on the analyst's assumptions. Let's say the market price of the stock is $130. What's the implied growth rate that investors are pricing in? Using the Gordon growth model, we rearrange the terms to find the growth rate. This may require you to flex a bit of your algebra skills, but it shouldn't bother you too much. The implied growth rate turns out to be around 5%. As the calculation is complex, you may want to verify your answer with the GGM formula to make sure you didn't make any mistake. So, over here we have an implied growth rate of 5%, which is higher than the analyst's estimate of 4%. As the investors believe in a higher growth potential for the firm, they're willing to pay more than the intrinsic value estimated by the analyst. Before we proceed, here's a quick note regarding growth rate under the GGM. Thus far, we've been referring to the growth rate as the expected growth rate in dividends. Implicitly, it can be shown that this growth rate also refers to the value appreciation of the firm and earnings growth. If we multiply both sides of the equation by 1 plus G, we get the following expression. The right-hand side is actually V1, so we have the relationship that when the dividend grows by G, the value of the stock also grows by G. And given a constant payout ratio, earnings also grow by G when dividends grow by G. In essence, the growth rate under GGM refers to all these three components, so we can use them interchangeably. Speaking about earnings and payout ratios, another application of the Gordon growth model is to calculate the justified price-to-earnings ratio of the firm based on the firm's fundamentals. If we divide both sides of the equation by current earnings, E0, we get this equation. On the right-hand side, we have the current dividend divided by current earnings in the numerator. This is the current dividend payout ratio. As the payout ratio is 1 minus the retention ratio, another way of expressing this is as such, where B is the retention ratio. On the left-hand side, we have the value of the stock divided by the current earnings. To make it more consistent with P/E ratio, the notation for value here is often switched to P0, though you should be clear that this does not refer to current price. We call this the justified trailing P/E ratio for the stock. However, since investments are often forward-looking, analysts are more interested in the justified leading P/E ratio of a stock. Using the same approach, we divide both sides of the GGM equation by next year's projected earnings instead of the current earnings. In this case, we have the expected dividend payout ratio for the next period. Likewise, if the payout ratio is expected to remain constant, we can express it in terms of the retention ratio. Similarly, we change V0 to P0 to make the notation consistent with PE. So, in essence, the justified PE ratio of a stock is rather simple using the Gordon growth model. You do not even need the earnings or dividend of the company. As long as the company has a consistent payout or retention ratio, the justified PE ratio is simply a function of the payout ratio, required return, and growth rate of the stock. Looking back at our example of XYZ stock, let's say the current $5 dividend was paid out from earnings of $6.25. Calculate the justified leading PE and justified trailing PE of the stock if the growth rate is estimated at 4% and the required return is 9%. Pause the video now and work out your answer. And we're back. First, let's determine the three parameters required to calculate justified PE. The payout ratio is the dividend divided by the earnings, which is 0.8. Required return is given as 9% and growth rate at 4%. And let's plug these figures into the formula for justified leading PE. That gives us a justified PE of 16 times. And likewise for justified trailing PE, that gives us 16.64 times. You may have noticed that the justified trailing PE is simply the leading PE times 1 plus growth rate. This means that the justified trailing PE should always be higher than the leading PE. This makes sense, as we expect the next period's earnings to be higher, so the leading PE should be lower. Now, let's explore a hypothetical scenario. Let's say XYZ has a dividend payout ratio of 1.0. That is, it pays out all its earnings to shareholders, so it does not retain any of the earnings to grow the company. The growth rate of the company can therefore be assumed to be 0. In such a case, what should the justified forward PE of the stock be? Pause the video now and work out your answer. And we're back. If we plug in the figures into the formula, we should get a PE of 11.1. Compare this with our earlier calculation of 16 times leading PE, and we can interpret that difference in PE, that's 4.9 times PE, is attributable to expected growth of the company. We can also use this argument to segment the firm's equity value into two components. Using the Gordon Growth Model, we have earlier estimated the intrinsic value of the stock at $104. But if we assume full payout and 0 growth, the next dividend would be $6.25, so the value of the stock is just $69.44. This means that the stock value due to growth is $34.56. We call this the present value of growth opportunities, or PVGO in short. The generalized formula for PVGO is therefore the intrinsic value of the stock minus E1 over R, where E1 is the forward earnings. You may be wondering, why is it not D1? In effect, it doesn't matter, because this component is calculated based on 0 growth, which means 100% dividend payout, so the earnings is equal to the dividend. I hope you see the relationships here. The value of a growing company can be segmented into two components. If the payout ratio is less than 1, it means the company is retaining cash for growth opportunities, so there is expected growth in company value and dividend. This results in a higher intrinsic value of the stock than the case where the company is not expected to grow. The difference due to expected growth is the PVGO. The other component, which is not dependent on growth, is also known as the value of the company's assets in place, which means that the company's assets continually generate returns equal to the required return of the stock. In general, companies in slow growth industries like utilities have low PVGO, and most of their value comes from their assets in place. In contrast, high growth potential sectors like the tech sector tend to be valued more based on their PVGO. With that, let's practice. Zoom Plus is a tech company, and its shares currently trade at $120. The company has expected earnings of $3 per share, and the shares have a required return of 15%. Determine the proportion of the company's leading PE ratio that's attributable to PVGO. Pause the video now and work out your answer. And we're back. First, let's calculate the PVGO, which is the value of the company minus E1 over R. This gives us a PVGO of $100. Based on the stock's current price, the PE ratio is 40 times. And the PE attributable to PVGO is 33.3 times. As such, 83% of the firm's leading PE ratio is attributable to PVGO. And lastly, another application of the Gordon Growth Model is the valuation of preferred stock. This is really quite simple. We know that the dividend for preferred stock is fixed and is paid at regular intervals for perpetuity. So the next dividend is the same as the current, which is the fixed dividend payout. The growth of dividend for preferred shares is 0, as the amount is fixed for perpetuity. As such, the value of preferred stock is simply the fixed dividend divided by the required rate of return. It's that simple. Let's try this out. XYZ Company has preferred stock issued at $100 par that pays a fixed 7% dividend each year. Based on a required rate of return of 9%, what is the intrinsic value of the stock today? Pause the video now and work out your answer. And we're back. That was easy, wasn't it? The par value is $100, so a dividend of 7% works out to $7 each year. Divide this by 9%, and that works out to $77.78. And to conclude this lesson, let's briefly discuss the strengths and limitations of the Gordon Growth Model. Firstly, it's applicable for valuation of stable, mature, and dividend-paying firms. However, this also infers the limitation that it cannot be easily applied to non-dividend-paying firms. The model is also appropriate for valuing market indices and can be used to determine implied growth rates, justified PE ratios, and PVGO. Moreover, the model is easily communicated and explained because of its straightforward approach. The flip side to this is that valuations are very sensitive to estimates of growth rates and required rates of return, both of which are difficult to estimate with precision. As such, unpredictable growth patterns of some firms would make using the model difficult and the resulting valuations unreliable. Nevertheless, due to its simplicity, the model can be used to supplement other, more complex valuation methods. And that concludes this rather long lesson on Gordon Growth Model. We've got more interesting stuff lined up for you. In the next lesson, we'll learn to extend the GGM to multi-period models. Take a break, and see you at the next lesson.